shall be looking at the classification of partial differential equation, that is the PDE. Partial differential equations. How to classify them. The general formula for the classification of partial differential equation is A, second partial derivative of u with respect to x squared, plus 2b, second partial derivative of u with respect to x and also with respect to y, plus c, partial square derivative of u with respect to y squared. Obviously, these are all second orders. When agglomerated together, you equate it to a first order relation, which is starting with coefficient d partial u partial x plus coefficient e partial u partial y plus fu plus g, a constant. Note that this is the general expression for the discriminant test analysis of a partial differential equation of the second order. Discriminant in the sense that we will use this relationship to relate it with the almighty formula or the general quadratic formula to discriminate a partial differential equation. However, it is pertinent to know that the parameters that will be used for the discriminant test are letters A, B, and letter C, which are all constants. Let us also understand that the variability of x, y can also extend to t, which is not here. However, the domains are x and y. The discriminant test analysis that will show if the nature of the partial differential equation for classification, if the nature is elliptic, parabolic, or hyperbolic, depends on the discriminant test. When A multiplies C is greater than B squared, it is said to be an elliptic function. It's elliptic. Also, when A multiplies C is equal to B squared, it is said to be a parabolic function. However, and lastly, when A multiplies C is lesser than B squared, the function is said to be hyperbolic. However, there are a lot of calculations that can be resolved in order to test if an equation is hyperbolic, parabolic, and elliptic. Some of these are wave equations like partial square u partial t squared is equal to alpha squared partial square u partial x squared plus partial square u partial y squared plus partial square u partial z squared for functions of 3 variables in a state space plane. Over time, a lot of examples will be given on this parameterization and the application in order to determine the elliptic nature, parabolic nature, and hyperbolic nature. Of course, because of the tripartite axial relationship, it is limited to one variable system amongst these, such as partial square u partial t squared is equal to alpha squared partial square u partial x squared. If limited to this, then it will be easy to ascertain the nature of the curve, if it is elliptic, parabolic, or hyperbolic.